All right. So let's look at some examples on second order differential equations. In the previous video, we looked at the introduction in terms of how we come up the auxiliary equation. Um, Now, we also understood where like we also understood the part of the possible solutions that we can have. Of course, we are using the values of m1 and m2 that we get from the auxiliary equation, or you can use the uh, you can use p and q, that is if you have complex roots. So it all depends on the values of m1 and m2 that we find. Okay, so the first example that I'd love us to look at is let's say we have d2 d2y dx2 minus 12 dy dx plus 36y is equals to 0. So always remember, the first step that you have to take is that come up with your uh, auxiliary equation. Okay, so in this case, what it is that we can write this as m squared. Okay, m squared minus 12m plus what, plus 36 is equals to 0. That's how we can write that. Okay, so now we just have to factorize the product. We know is 36, the sum is 12. Two numbers, I multiply them, I get 36. That's negative 6 by negative 6. I add them, I get negative 12. Okay, so here I'm going to have m2 minus, sorry, m squared minus m 6m minus 6m here plus 36 is equals to 0. So I'm going to have like m here, m minus 6. So I'm going to have like minus 6 here. That would be m minus 6 there is equals to 0. So this is simply m minus 6 by m minus 6 is equals to 0. So meaning you have like, you can write this as your m minus 6 squared is equals to 0. So which indicates that your m1 and your m2 are equal. So you have real equal roots. So having real equal roots, this is what we use to come up with the solutions for that differential equations. I mean, for that differential equation rather. So in this case, our m1 is equals to positive 6. Okay, so we can now say, all right, we can pick this as y is equals to that would be your a plus your bx, then that would be your e to the power 6x, like that. So this happens to be the solution that we are looking for. Very, very simple and straightforward. It's just a matter of you identifying what type of the roots that you have. Okay, so let's look at another example. So let's say we have d2y dx2 plus 7y is equals to 0. So this is simply m squared plus 7, uh, uh, that would be plus 7, what, just plus 7. Yeah, it will be just plus 7 because the m, we get it from the um, we get m from dy dx. Okay, the other part is a constant, so that's what we have. So meaning our m2 is equals to negative 7, negative 7 there. So meaning we're going to have m being equals to positive or negative the square root of negative 7. Okay, so we can now write this as, instead of me writing like this, I'm going to say this is m is equals to positive or negative square root of 7, what, 7i. So how I get this is that I know I had like square root of negative 7, so this can be written as square root of negative 1 multiplied by square root of positive 7. Square root of negative 1 is simply I, which is the, we understand that from complex numbers. Okay, so we have determined that our m is equals to positive or negative the square root of 7, what, 7i. So remember, when it comes to complex, these are complex roots. It's a situation where you have like um, you have your p. Is it a p? Um, yeah, like more like the format or something. You have your p, positive or negative, uh, positive or negative iq here. Okay, so in this case we don't have a p. Our p is equals to 0, then our q is equals to square root of 7. So what we do is that we get this. I'm going to say y. Okay, I'm going to say y is equals to e to the power px. In this case my p is 0, so 0 by x is still 0. E to the 0 is a 1, so I'm going to have like a. Okay, a cos, what's my q? My q, I found that my q is square root of 7, so it's to be square root of 7, uh, square root of 7 x there, like that. Then that will be plus b sine square root of 7 x, like that, and that's a solution. Okay, let's look at another example. Let's say we have d2y dx2 um, plus 2 dy dx minus 3y is equals to 0. Okay, so now this can be written as m squared plus 2m minus 3. Okay, so here we observe to say the product is just a matter of factorizing. The product is negative 3, the sum is 2, so you are simply saying 3 multiplied by negative 1 giving us negative 3, then plus 3 minus 1, that will give us plus 2. So that is m2, I'll say, plus 3m minus m minus 3. So this will be like m plus what? M plus 3, that will be minus 1 here, so I'm going to have m, that will be plus what? Plus 3 there. So this is going to be m minus 1, so m plus 3. So you observe to say in this case I can say my m1 is equals to 1, then my m2 is equals to negative 3. Okay, so those are the roots that we have, and looking at the way they are, that's those are real distinct roots or real different roots. Okay, so meaning you can use this equation y is equals to a e. Okay, our m1 we have found is 1, so we can just say x there, plus b e our m2 is minus 3 x, like that. And that's simply the solution that we have for that particular differential equation. Okay, very very straightforward. Just make sure you find um, the correct values of m1 and m2. So now let's say we have something that's a bit different. Let's say we have 2 d2y dx2 plus 4 dy dx plus 3y is equals to 0. Okay, so we need to come up with the auxiliary equation from that differential equation that we have. So this is going to be 2m squared plus 4m plus 3. Okay, so here I can't really factorize, but I can use the quadratic formula to come up with the solutions for m. I can say my m is equals to that's going to be minus b, which is in this case my b is a 4, positive or negative, the square root of b squared, in this case is going to be 16, minus 4, which was my a, 2 was my c, 3. That's going to give me something like a 24. We are saying 4 times 2 times 3, we are going to get 24, divide by 2a, 2 times a, that will give us 4. So our m is going to be equals to minus 4 positive or negative, we are saying 16 minus 24, that will give us minus 8. Okay, divide by 4, like that. So m is going to be equals to um, that will be minus 4 positive or negative, we're going to get 2 root negative 2. Okay, where am I getting this from? um, that is simply 2 multiplied by negative not like that. Let me write it as 4 multiplied by negative root 2. Wait, I say root 4 multiplied by root negative 2. This and that are one and the same thing, so the square root of 4 is a 2, then the other part remains. So we are still dividing by what? We are still dividing by 4. So I can write this as my m is equals to minus 4 positive or negative. That's going to be 2 root 2 I. Okay, 2 root 2 I there. Then we are dividing by 4. So having said that, we can try to simplify this a little bit further again, because I want to write it in terms of p and q. So that's going to be m is equals to, that will be minus 1. Okay, I've just divided both this and that by what? By 4. So this is going to be positive or negative uh, root 2i divided by 2. Okay, so in this case our p is negative 1, our q is 2 over root 2. So those are those are complex roots. So we can come in and say y is equals to e to the power, what's our p is negative 1, so that would be minus x there. Okay, so then you can say it's a equals, our q is 2 root, root 2 over 2, then by x there, then plus that would be b sine root 2 over 2 x, like that, and that's the solution that you're looking for. You can decide to put this e to the minus x on the denominator. You're going to have y is equals to a cos 2 root 2 over 2x plus b sine root 2 over 2 x there, divided by what? Divided by e to the x, and that happens to be the solution of that differential equation. So now let's look at the last example in this tutorial. So let's say we have d2y dx2 minus 9y is equals to 0. So this is simply m squared minus 9 is equals to 0. So this happens to be, say, m squared is going to be equals to 9. So m is going to be equals to positive or negative 3. So here, don't make a mistake saying you only have a 3. Then you say, okay, these are real equal roots. No, that would be wrong. When you square root this value, you're going to get a positive value or a negative value of it, because when I bring it back here, if I put positive I get 9, if I put negative I still get 9. So that's why there are two solutions for that one. So those are real different roots or real distinct roots. So we're going to say is y is equals to ae, my m1, let me say my m1 is 3, then x there plus be my m2, let me say is minus 3 x, like that, and that's what we happen to have as a solution. We can see write it as y is equals to a e to the 3x plus 1 over, or in this case let me say b over wait b over e to the 3x, and that's the solution right there. And that's simply how you go about answering those questions on second order differential equations. Thank you very much for watching.